In the previous video, we saw what we learned and know as functor so far is actually a kind of functor called covariant functor. Covariant functors are like containers that hold or deliver us some type. We also learned about contravariant functors, which are functors that depend on a type. You may hear that contravariant functors are producing a type, while contravariant functors are consuming a type. In this video, we will see how to implement contravariant type class. We will also look into predicate structure and use it as an example for contravariant instance. Alright, let's get into it. First, let's import the stuff that we need. We need HKT, kind2, URIS, URIS2 from FPTS. If this looks new to you, please check out my video on type classes in FPTS. The other thing we need is our compose function, and I have a dedicated video on composing functions as well. Next, let's define our contravariant type class. So, structure F is contravariant if it has a contramap method on it. Contramap is a generic function. It first receives a function from B to A. It then receives f of A, which we showed with HKTFA, and returns f of B, which we showed with HKTFB. Let's not forget about our URI. Because of the way we model type classes in TypeScript, we need to define separate interfaces for each kind of our structures. So let's do that. Interface contravariant 1 for structures of exactly kind 1. We enforce that by extending f from URIS, meaning structures that exactly have one type parameter. The control map is similar to before, except we're going to replace HKT with kind 1. So, FA, instead of HKT, we say kind, and it returns kind FB. For the sake of this video, let's do that for structures of kind 2 as well. Contravariant 2, F extends URIS2, meaning structures that have two type parameters. Contra map, this time a generic function with three type parameters. F again receives B and returns A. And then this function receives FA, which is of kind 2, FEA, and returns kind 2, FEB. And we also forget about our URIs, so let's add them. Now that we saw how to define contravariant type class, let's look at an example of a structure that is contravariant and implement an instance for it. Before that, let me create a little bit of a space here. Let's consider a structure predicate that receives, consumes, or depends on something and maps it to true and false. You're already familiar with this structure. This is exactly what you use when you are passing a function to filter. What you pass to filter is a predicate. Before we define a contravariant instance for predicate, as a boilerplate, we need to add it to URI to kind interface. So let's do that. Module FPTS HKT. If this looks new to you, I have a demo video on type classes in FPTS, so please check out that video. Now we are ready to define our contravariant instance for predicate. So let's do that. Predicate contravariant of type contravariant 1, because predicate is of kind 1. Let's add the URI predicate, and our control map looks like this. It first receives a function from B to A. It then receives a predicate of type A, and it needs to return a predicate of type B. How can we do that? Well, predicate of type B, it receives a value of type B and maps it to true and false. In order to do that, we first going to call f with b and then call predicate A on top of it. And this is our control map method for our predicate contravariant instance. But we can summarize this more. Take a look at this part. This is a function composition, right? So let's rewrite this. Compose predicate A and F, and let's get rid of the last parentheses. Another simplification we can do is, if we look at this part, B is happening on the both sides, so we can cancel it. Let's do that. And this is our predicate contravariant instance. Let's try our instance with an example. Let me make a little bit of space here. Let's consider a function is number even that receives a number and returns a boolean. By now you know that this is actually our predicate number. Let's define this. Is number even of type is number even. What it does, it receives a number and we're going to check to see if this is even. Next, let's consider a length function. It receives a string and returns a length of it. Implementing this, type length, it receives a string and returns the length of it. Now what we want to do is to lift our length function to the predicate context. Meaning if the length function is from string to number, using our predicate contravariant instance, we want to lift this to predicates of number to predicates of a string. Let's do that. Type lifted length. It receives a predicate of number and it's going to return us a predicate of string. Let's calculate this. Lifted length of type lifted length. We use our predicate contravariant, call control map over it and pass our length function to it. So now we can calculate our is a string even predicate pretty easily. Let's do that. So const is a string even of type is a string even. What we want to do is we want to call our lifted length and call it with is number even. Let's try this with some examples. Console log is a string even. Let's call it with book. If I save, we get true, because the length of a string book is even. And if I try this with, for example, book 1, if I save, we get false because the length of book 1, a string, is not even. And with that, thank you for watching this video. Please like and subscribe, and I will see you in the next one.